All right, let's go over how to solve a problem like problem 3.1 in our book. The problem reads, the two roots of a quadratic equation, ax squared plus bx plus c equals 0, can be obtained using the following formulas. And they have an r1 equals, and then they have a formula, and r2 equals this formula. B squared minus 4ac is called the discriminant of the quadratic equation. If it is positive, the equation has two real roots. If it is 0, the equation has one root, and if it is negative, the equation has no real roots. Wow, that sounds like a branching statement to me. Write a program that prompts the user to enter values for a, b, and c and displays the result based on the discriminant. If the discriminant is positive, display two roots. If the discriminant is 0, display one root. Otherwise, display the equation has no real roots. That'll be the easy one. Note that you can use math.pow with two parameters, so we send it two arguments, to compute the square root of x. Here are some sample runs, and they give us some sample data. All of our programming problems will have an input, some processing, and then an output. Our input for this program will be the prompt to the user to enter the values for a, b, and c. Our processing will include checking those values and performing the correct equations. And then our output will be the results of those equations. Let's start programming in Eclipse. First order of business, let's create a new class for our program. So right-click on any of your project folders and go to New Class. You can call this class whatever you want. It is standard practice to name your classes with a capital letter, so please follow that Java standard. I don't really mind what you call your class name, but follow the standard of having a capital letter here at the front. Go ahead and hit finish. And I forgot to copy our static main. So I'm going to go ahead and copy that. Or you could have check marked that box in Eclipse to have it write this line of code for you. Or alternatively, type it out yourself. Alright, first order of business, let's get our input from our user. We need our input for our variables a, b, and c. So we must declare. If you forget what kind of variables you need, go ahead and look at your programming problem. You're going to have the user enter in the values for a, b, and c that are going to be part of our quadratic equation. Now, as I've told you before, you should name your variables good variable names. So let's go ahead and decide that we're going to make these a double value because they could be decimals. And we'll go ahead and name them var A, var B, and var C. Go ahead and output to the user. Please enter in the value of variable A. To get input from our user, remember that we use this line of text where we create a keyboard object of type scanner, which allows us to get information from the keyboard and from our operating system. You'll have to include the scanner library, so if you hover over that word scanner, if it's red underlined in Eclipse, go ahead and click on import this library here. The java.utils library contains the scanner class, so it goes ahead and writes the import statement here at the top for us. Alternatively, you can just type that in yourself. Alright, now we can use this keyboard object. Use your Control C and Control V, and we'll go ahead and get the next. We want to get the next double in from the keyboard. So go ahead and you look for a method of the scanner object that'll allow us to get the next double. And if you don't remember, then you can scroll down inside of these little shortcut help boxes that pop up in Eclipse, and there's our next double method. That'll go ahead and ask the operating system for the next double that was typed in at the keyboard. We need to store that variable inside, or store that value into our variable. So we'll go ahead and write var a is assign the value of what our scanner object is bringing in from the keyboard. Now we're going to go ahead and get the other two variables very similarly. So I'll just copy and paste those lines of code. And remember to get the correct variable on the left-hand side of your assignment statement to store that value correctly in the correct memory location. Now comes our processing part of our program. In our processing part of our program, we have a little bit of intelligence here in our program. We have to decide which output needs to be displayed, either 2 outputs, 1 output, or 0 outputs. So write a program that prompts the user to enter the values A, B, and C and displays the result based on the discriminant. The discriminant is b squared minus 4ac. So this is what we need to calculate so that we can check the value of this inside of our branching statements. So we'll make a variable of type double and we'll call it discriminant. Notice I'll add him to my initializations here at the top. Add him to my variable declarations here at the top. Then I'll go ahead and use him to hold the value of my b squared minus 4ac. So it'll be var b. Now there's a couple ways that you can calculate b squared. You can just multiply it by himself, and there's b squared. And then we'll want to subtract the value of 4 times variable a times variable c. Note another way to calculate this discriminant is to use a math function that you might have read about in your textbook. And it is a known math function that will be a part of every programming language, would be the POW function. Usually in a library called math in most programming languages. But if I go ahead and type in the class name math, notice it's a class name because it has a capital letter, and then put my dot operator, it'll bring up all of the variables, constant variables I have access to, part of that math library, and all of the methods I have access to, part of that math library. And one of the methods, our function in every math library, is this POW function, which raises to the power the first parameter, which is our a, raised to the second parameter of b. So when I write my call to this function POW, my first argument would be my variable b, because I want him, variable b, raised to the power of 2. So my second argument that I send to this POW function would be the power I'm raising this variable to. So raising variable b to the power of 2. Notice that this line of code gives me the same result as this line of code. But I only need one of them, so I'm going to comment out one of them. Alright. Now we've done some processing, and now we'll have our branching statements. Based on this discriminant value, we'll know how to calculate the rest of our equation and also what output we should have. So looking back at our specifications here, if the discriminant is positive, display 2 roots. So how do we check if something is positive? We check if it's greater than 0. So our output 2 roots. Then we had to check for another case inside of our problem. If the discriminant is 0, display 1 root. How do we check if something is 0? We say, are you equal to 0? Remember, it's 2 equal sign to check equality. So in here, we'll display 1 root. And then the last part of our branching statement will be our else part. And of course, if it's not positive and it's not equal to 0, there's only one case, meaning that the discriminant has to be less than 0. If it's less than 0, in our programming problem, it says, display the equation has no real roots. This is an easy one. We just have to display the equation. The equation has no real roots. All right, let's output our 2 roots. So we look back at our equation and we see that root 1 is negative b plus the square root of b squared minus 4ac over 2a. So in other words, we just have to write this equation in our programming language. So it'll be negative variable b plus the square root of b squared minus 4ac. Now the b squared minus 4ac is our discriminant. And how do we take the square root of something? He gives us a hint down here at the bottom. He said you can use math.pow with the second argument set to 0.5 to take the square root of the first argument that you send to this function. So we can use this math.pow function with our discriminant as the value of x. So we'll write math.pow. In here we'll put our discriminant. Remember to copy and paste when you can. And then our second argument, we'll give it a 0.5. And that'll take the square root of our discriminant, which is our b squared minus 4ac. Now we want to take this whole value and put it over 2 times a. So remember your parentheses. And we'll divide it by 2 times variable a. And there's our first root. Our second root is very similar to our first root, so we can copy and paste this. Looking back in our problem, our second root just has a subtraction symbol here instead of a addition symbol. So in our second root, we can change this to a subtraction symbol. And then importantly, name him a different variable name than our first variable, root 1. We'll call him root 2. We'll declare him at the top, and of course, initialize him here inside of our if statement. All that's left to do is output our values here. So if the discriminant is positive or greater than 0, then we'll output 2 roots. We'll output root 1. And then of course I'm going to copy and paste this line of code and change my 1 to a 2 to output root 2. Now inside of our else if discriminant is equal to 0, I only want to output one of my roots. Now the only thing is I'm calculating this root inside of my if statement. So my choices are I could copy and paste this calculation into my else if, or place it outside of my else ifs. I'm going to go ahead and copy it inside of my else if. This way I'm being a little tiny bit more efficient because I'm only doing the calculations depending on if my discriminant is either greater than 0 or equal to 0, and I don't bother doing calculations if it is negative. Now it's all left to do is to test to make sure that we are getting the right values and output for some given input. In the problem, he says, go ahead and test it with the values 1.0, 3, and 1, and you should get this as your output. These are good values to start with. So we'll go ahead and we'll run our program. Of course, we're right here in our program where we're entering the value of the variable a. And then we'll enter the value of variable b and the variable c. I think I gave it the wrong input. And it says the equation has no real roots, which is good. We tested that. Let's see here. It was 1.03 and then 1. So let me test it again. We tested our else branch. And we got some values for root 1 and a good value for root 2. And looking back at our problem, those are the same values that he has output here. Now he has it output to a certain amount of decimal places. And if you'd like to learn how to do that, I can show you. So a little bit extra here, if you'd like to format to a certain amount of decimal places, we'll use a class called decimal format. This is part of the Java API called the decimal format class. And this is a good way to kind of format a double variable to a certain amount of decimals. So what I'm going to do is I'm going to make a new decimal format object, kind of like how we made the scanner object that we named keyboard. And we made it to get input from the user. We're going to use this decimal format object I called formatter to go ahead and we're going to utilize our formatter object to format our decimal numbers when they're output. And so inside of the constructor for my formatter object, I'm going to go ahead and tell it, go ahead and put any amount of numbers in front of the decimal and after the decimal. That'll make it mandatory that there's 5 decimals after that decimal. I'll go ahead and use my formatter object now when I do my output. He has methods just like our keyboard had methods. Our scanner object had methods. So this formatter object has methods, and one of his methods is the format method. And in the format method, you give it a double value as an argument, and it formats it to how you constructed it up here to format. So just to see how this works, we'll go ahead and copy and paste him here. Remember to triple click, Control C, triple click, Control V, Control S for save. Go ahead and run your code again. And we can give it the same test values we did before. And we can see that because I put the hashtag or the pound symbol in the front, that means it was optional to print that number. But because I put the zeros here in the back, it was mandatory that there have 5 decimal places. So if I want that 0 to appear here in the front, I could replace it in my formatter object with a 0 instead of a hashtag. And then when I run this thing, you can see the 0 appears here in the front to the left of the decimal place. All right, that concludes the explanation of problem 3.1 of your text. Utilize this example as an example for your homework problem.